Today we're looking at dividing radicals. Yesterday we looked at multiplying radicals, and multiplication and division of radicals is very similar. And so as we look at dividing radicals, we're not going to do this initial investigation, but we're going to skip right into the rules of dividing radicals. And so when we're looking at dividing radicals, very similar to multiplying radicals, we need to divide the numerical coefficient by the numerical coefficient. We need to divide the radicand by the radicand. And lastly, we need to make sure that it's simplified into the mixed radical form if possible. So in this first example, mix numerical coefficient by numerical coefficient. So the numerical coefficient here is 1 and 1, so we don't need to do anything. But divide the radicand by the radicand. So 70 divided by 7, we would be left with root 10. This next example, coefficient by coefficient, we get 15 divided by 5 is 3. Root 18 divided by root 3, we get root 6. In this next example, 20 divided by negative 4, we would get negative 5. And 40 divided by 5, we get root of 8. And here's an example where we can simplify a little bit further. So negative 5 would be 4 times 2, or negative 5 times 2 root 2, or negative 10 root 2. And my last example here, well, actually I'll do this example. X by x, we would have the root of y. And my last example, 10 divided by 20 is 1/2. So I would have 1/2. And 24 divided by 2 is root of 12. And so we could write this like this, root 12 over 2. But we can simplify this root 12. This root 12 can be simplified into the square root of 4 times 3 over 2, or 2 root 3 over 2, which those 2's would cancel out, and we'd be left with the square root of 3 as a final answer. Now in this example, we want to simplify the numerator and the denominator, and then we want to divide. So first of all, in simplifying the numerator and the denominator, we want to make sure that this is my smallest mixed radical as possible. So this 4 root 54 can be expressed as 4 times square root of 9 times square root of 6 divided by 3 times the square root of 4 times the square root of 2, which we would say is 4 times 3 times root 6 and divided by 3 times 2 times root 2, which would give me 12 root 6 over 6 root 2, or 6 goes into 12 2 times, 2 root 3. So notice how the first thing I did was I simplified into my smallest mixed radical, and then in order to solve it, I canceled like terms or divided my lowest common multiples, and then I simplified again to my smallest mixed radical. Now we want to divide each term in the numerator by the denominator and then simplify. So I want to divide root 20, root 40, and root 90 by this root 5, and then I want to simplify. So root 20 divided by root 5 is going to be square root of 4 plus the square root of 10 minus, having a brain fart here, square root of 18. And now we can simplify these into the simplest form. Well, this is going to be square root of 4 is going to equal 2 plus the square root of 10 minus square root of 9 times 2, which is 3 root 2. So if I bring it up here, 2 plus root 10 minus 3 root 2. And that would be my final answer. It's as simple as we can get. Now, our last example that we're going to look at is known as rationalizing the denominator. Now, in order to rationalize the denominator, we don't want to have a radical on the bottom. And so we would go through a process called rationalizing the denominator. And the way this works is, usually if we write something in simplest form, for example, 1/6 plus 1/3 would be 3/6, which we could simplify to 1/2. With radicals, however, when we rationalize the denominator, we don't use a radicand as a fraction. So our final answer, we don't want to have a fraction as a denominator. It's okay if we have a fraction as a numerator, but not as the denominator. And so this process, we would, if I have a fraction, 1 divided by square root of 10, in order to rationalize the denominator, I would multiply the top, I would multiply the whole expression by the square root of 10 and the square root of 10, like so. When I do that, I would have 1 times the square root of 10, which would be square root of 10, and the square root of 10 times the square root of 10, which is the square root of 100. And we know that this is going to be the square root of 10 over 10 as a final answer. And eventually you'll come to be able to shorthand this and know that if you multiply a radical by a radical and it's the same number, then it'll just get rid of the radical. So in this next example, again, rationalizing the denominator, we multiply by the square root denominator. So root 20 over 2 root 6, we multiply by root 6, and we would be left with the square root of 120 on the top here, divided by 2 times the square root of 36, which we know that we can simplify to 120 divided by 2 times 6, which is 12. All right, in this next example, then, what we want to do is simplify by rationalizing the denominator and express each in simplest radical form, and then we want to rationalize the denominator. So in simplest radical form, I'm going to express this one as 100 times 5 and 27 as 9 times 3. We can then express this as 10 root 5 over 3 root 3. So now I want to rationalize my denominator by multiplying by the root of 3 on the top and the bottom. This is going to be leaving me with 10 root 15. 5 times 3 is 15. And root 3 times root 3 would be root of 9, or 3. So 3 times 3 would give me 9. And this would be my final answer. This last example I'll do exactly the same thing. Now, 240, we're looking for perfect squares that are going to go into 240, and we might want to start by thinking about numbers like 4, 6, 8, numbers that go into 240. But since it's such a big number, we might want to think of the perfect squares. So for example, 36, that doesn't go in evenly. What about 16? That does go in evenly 15 times. So I can express this as 3 root 16 times 15, and 108, we know that 108 is divisible by 9, but also 27, which means that it's also divisible by 9. Now, if I pull that 9 out of there, I know there's also going to be a 4 that I can pull out there. So 108 divided by 16 doesn't work, but 108 divided by, let's go with 49, also doesn't work. 108 divided by 64, 108 divided by 81. So let's start small. We'll start with our 9. So 9 times 12. And the 16 times 15, I pulled the 4 out of there. So this is going to be 3 times 4 times the root of 15. And on the bottom, I'll have 3 root 12, which can be simplified even more. So 3 times 4 is 12, root 15. 3 times 4 times 3 is going to be 12 root 15 over 2 times 3 is 6 root 3. And now I can simplify this even further. And I'll take it up here now. 12 over 6 is 2. And 15 divided by 3 is going to be root 5.